trace of a line inclined to the VP. So we just looked at trace of a line inclined to the HP. All right. So here we will have our pictorial representation. So here we have the line in this case now. So we have a line here now, and the line is inclined to the VP. All right, it is inclined to the VP while being parallel. So this line is said to be parallel to the HP, but it is inclined to the VP. Let's set it up. All right, so as we can see here is that, remember that once we look this way, this will be our front, right? So this will be the front. And once we look this way, right, once we look down on the line AB, this will be our plan. All right, now obviously it is inclined, the line AB is inclined to HP. Notice that it's at an angle, while with the H it's inclined to the VP, right? Inclined to the VP, while it is parallel to the HP. Now, once we project this line, if we project this line, can we project this line? If we project this line, will we get a trace? No, we will not get a trace because this is parallel. All right, so we'd have to project this line. All right, so once we project this, we'll get the trace. So once we get the trace here, we can move from there. All right, so here now we have so that will be the trace. So here now over the orthographic representation, we will see how we get the exact location of the vertical trace. And again, we know how we get these, right? So this would be our XY axis, right? So this is our XY axis, and therefore the distance from here to A prime, the distance from here to B prime would give us these distances, right? This distance, while the distance from XY to A gives us the location of A, and the distance from XY to B gives us the location of B. So once we set up the orthographic, and again, this would be our front, this would be our plan. So we are going to project from AB to get our trace, right? And the trace will touch our XY. Good. So once we project the trace, or once we project the extension of AB and it touches XY, then I wonder if you remember this, that if this is HP, then once it touch here, we're going to get V. If this is VP and we should project and it touches the XY, we would get H. Just remember that, all right? So here we have V. So we're projecting from HP, so we'll get V. Now, this would be our trace. Now, once the trace touches XY, we're going to get a perpendicular line up and a line to intersect, which would be an extension from A prime, B prime, and this would be our vertical trace. That would be the exact location of the vertical trace. And of course, all right, so we're going to be looking now at the application of what we just learned a while ago. Traces of a line inclined to the VP and traces of a line inclined to the HP. All right, so let's look at this one. Setting up the apparatus. So we have our VP or HP, and we have a line, right? So here we have a line AB. So both these lines are inclined to VP and HP. So if we extend this line, Remember, we're coming from V. So if we extend this line, what will we have here? H. All right. Similarly, we extend this line. We're extending from HP. So therefore, we should get what there? V. All right. So this would be the horizontal trace, and this would be the vertical trace. All right. Now, we want to find the exact location of the horizontal trace. So therefore, from the horizontal trace, we project a perpendicular line which will cut the extension or the trace from the vertical trace. So this point here will give us the horizontal trace, and it would be the exact location of the horizontal trace. Similarly, um, we the projection from the line here will give us the intersection of the horizontal trace, and this point here will be our exact location for the vertical trace. All right. Now, do you remember how to find the true length of a line? So we determine the true length of a line by using three geometric methods. One, we can use triangulation. Two, we can use auxiliary. Or three, we can use rotation or revolving method. All right. So we're gonna work out a problem now, and we're going to incorporate several geometric principles that we should know or that we learned so far through lessons prior to now. So this will show how to get the true length of a line by revolving or rotation. So here we have our xy, and we have a line. So we have a line AB and A prime B prime, right? This here is our front, this here is our plan. So up here would be VP, and down here would be our HP. All right. So what we want to do to determine the true length of both these lines, the first thing we want to do is draw lines parallel to XY from each end of the line. So from A prime, we draw a line parallel to XY. From B prime, we draw a line parallel to XY. From A, we draw a line parallel to XY. From B, we draw a line parallel to XY. So all these lines are said to be parallel. Now, what we're going to do now, because we want to find the true length of AB, we want to determine the true length of AB. So if you're using the traditional method, then you'd put your compass point here, open it up to here, and we will rotate and scribe an arc. All right, so once the arc come and touch this parallel line, we'll just extend the line down. If you're using AutoCAD, then what you would do, you would just use AB as your radius, and you get a circle, and then you trim it, or you get an arc, whichever method suits you. You would do that. All right. So once the arc touches the line here, we'll extend this line down. Now from A to this intersection, we will get the true length of the line AB. Right? So I've just determined the true length of the line AB. So we want to determine the true length of A prime, B prime. We'll do the reverse. So doing the reverse would mean with our compass point here, open to here, so AB now as the radius, we'll scribe an arc. All right. So once we get this arc here, we'll extend this line up. Now where this line comes and intersect this line from A prime to here, we would get our true length. So this now would be the true length of A prime, B prime. All right, and this is the true length of AB. Good. So that is how we determine the true length of a line using rotation or revolving method. All right. So the key thing now is we want to determine now the true angle of inclination to the HP. Now, the true angle of inclination would be, once we get the true length of the line, then the angle that exists, if we were supposed to extend this, to touch XY, then the angle between the true length and XY would be our true angle of inclination to the HP. Similarly, if we should extend this line and find the angle there, which will be here, this would be the true angle of inclination to VP. That means extending this, whatever angle that we get here would be the true angle of inclination to the VP. All right, so we've just established how we determine the true angle of inclination to the two principal planes, all right, which is the true angle of inclination to HP, which is this angle here, so we can come all the way down here, so this angle here, or the true angle of inclination to VP, which will be this angle here. All right, that this line, so this line is at an angle here, and that angle is referred to as the true angle of inclination to the VP. Again, extend this line, then this angle here would be known as the true angle of inclination to the HP. What we want to do now is to find the traces of each line. So we want to find the trace of this line, and we want to find the trace of this line. All right, which we did already in subsequent videos, right? But we'll just so this is now like a refresher. So what are we supposed to do? We're going to extend. So our trace, that means this line here will be extended. All right, so once it cut, remember we're coming from where? This is VP, and this is what? HP. So when we come from VP, we're going to get H. So once the trace intersects the XY axis, then we're going to get H. So that point there will be H. Now, after establishing H, wherever H is, we need to drop a perpendicular line or construct a perpendicular line from H, right? So we'll have a perpendicular line from H. Now, the extension of our true length line here, will give us a point here, and that now would be the horizontal trace. So this is how we determine the horizontal trace, and this would be the exact location of the horizontal trace. Now, to do the vertical trace, we know that we have to extend this line. So this is the HP. So when we extend from the HP here and it touches the XY, we're going to get our V, right? And that now would be our vertical trace. So this now would be the location, right, for V. Now, projecting a perpendicular line from V, we'll see it cutting the horizontal trace line, right? So we'll get this point here. So this point would now be the location of the vertical trace, or the exact location of the vertical trace. All right, so again, this is our VP, this is our HP. So once we project from the VP, we're going to get H. Once we project from the HP, we're going to get V. So once H intersects the extension of V, we get the horizontal trace. Where the extension, where the perpendicular distance from V intersects the extension from H, we will get the vertical trace. All right.